All right, class. Oh, sorry, I'm on the wrong screen already. Today we're doing properties of logs, day 2. First thing we're going to learn is the change of base formula. Now, this comes from the fact that sometimes in our calculator, although the newer calculators do this, the older calculators only had log base 10 and natural log. So if you had a different base than 10 or e, you had to do a change of base so you could type it in and see the decimal approximation. So if you need to do that, think about if we set this, we would just set this equal to x. We would rewrite it as a to the x equals b. And then if you remember your log properties, you can like ln both sides and bring that down. So we get x ln of a equals ln of b. So we get x is equal to ln of a over ln of b. So this is basically the change of base formula. Look what it turns into. We turn this into that. So anytime you have log base a of b, you can rewrite it as natural log of b over, oh, I wrote it wrong over here. Whoops, ignore that. It should be natural log of b over natural log of a, because we divided by natural log of a. So it should be natural log of b over natural log of a, or you can write it as log of b with base 10 over log of a. And you also can always just set it equal to x and then solve as well, if you forget what change of base is. But basically it's log of the number over log of the base, of the old base. So let's do it. I'll just do them real quick. So this we can say, I'll do it both ways. I don't even know why we need to do change of base for this one, because this is already log 10. So you can literally type that one into the calculator, but if you want to change it to like natural log, you could say it's the natural log of 15 over the natural log of 10. That works. Over here, log of 5 over log of 3. And then what you do is you type in log of 5 divided by log of 3 in your calculator, because that button is right next to the 7, and you should get it's approximately 1.465. Over here, the natural log button is next to the 4 button on your calculator. So if you're with your calculator, you type natural log of 15, close the parenthesis, divided by natural log of 10, and when you do that, you get that this is approximately 1.176. Okay? So now, when you do log equations, there's a couple things you need to do. First thing you do is condense each side down to 1 log. Then you can either rewrite in exponential form, or the logs cancel if you have one on each side. What that's saying is, if you have log base a of like x equals log base a of y, then you can say that x equals y. Okay, we'll talk more about that tomorrow. So, here are the other properties and examples again of what we did yesterday. You can just quickly refer to those if you need to for the next page, but they are there for you to look at again. Alright, so now on the next page, write each expression as a single logarithm. So we're condensing. Now you have to be careful here, because this 2 is in front of this log here, which means that this whole thing is going to be squared. So I get log base 6, and if I square both those, I get x to the 4th y squared plus log base 6 of 12. Now I have a plus, so when the exponents are being added, that means these are being multiplied. So my final answer is log base 6 of 12 x to the 4th y squared. And that's it. Alright, the next one, we have to condense. Both of the powers are already up, so we're good there. So basically this just turns into log base 10 of 6x squared over 3x to the 1/3, I'm going to write it as. So that's that, and then we can simplify that. We get log of 6 divided by 3 is 2 on top. And actually, you also, for the x's, subtract So 2, which is 6/3, minus 1/3 is 5/3. So you can write this as 2x to the 5/3. And if we want to write it without fractional exponents, you would write it like this, if you remember correctly. That's the third root of x to the 5th. Or you could even pull one x out and it's x cubed, you know. I'm not as concerned about that right now. Alright, these here, we have to first bring our powers up, kind of like we did before yesterday. So when you do that, you're squaring this. So we get log base 2 of, if you FOIL that, you get 9x squared plus 12x plus 4. Plus, and then this is log base 2 of, if you cube that, you get 8x to the 6th. Let me just make sure this is right. 3 times 2 is 6. Yep, okay. So then we have multiplication here. So if you multiply this and this, you get 72x to the 8th. And then you get 96 x to the 7th, and then 8 times 4 is 32, x to the 6th. Okay? Alright, so this one, a little crazy, but it's okay. It's multiplying with these and then dividing by this. So, this turns into the NL. I'm going to do these multiplying ones first. The natural log of x over x minus 2 times x plus 2 over x. So what happens is the x's cancel, and then we still have minus the natural log. And I'm going to factor this because I know that it's going to have to come into play later. So I'll just do that. So now I have the natural log of this, which is, well, I'm actually going to do both things here. So we have x plus 2 over x minus 2 divided by this stuff. Okay? So if we simplify that, you flip it and multiply, the x plus 2's will cancel. So you get the natural log of, here I'll show you what it looks like. This is what it looks like. So these will cancel. And you're left with the natural log of 1 over x minus 2 quantity squared, which is the same thing as saying x minus 2 to the negative second. And then remember, for condensing, oh no, for condensing we can leave it like that. Sorry. Alright. Or you could leave it as 1 over x minus 2. I don't mind. Either way, squared. Alright, last two. Or 3, I guess we have. Now we're going to split these up. So I have multiplication here and division here, so right away I'm going to just write log base 7 of the first piece, y cubed, plus log base 7 of z, because they are being multiplied, and then they're both being divided by log base 7 of x to the 4th. Last step, write your powers as factors, so bring them back down. So I get 3 log 7 of y plus log base 7 of z minus 4 log base 7 of x. Okay, and that's it. Now this one, technically we can split up. So we get log of x squared plus log of x to the 1/4. And then we could bring the powers down. But on this one, you can also add these together. But since this says right as a sum or difference, we'll leave it like that. But technically, you could add these together because they're both log x. So but we'll leave those as is for now. Alright, and the last thing, express y as a function of x. So we have to get rid of the ln's, but in order to cancel out the ln's, we have to condense first. First thing you need to do to condense is move that back up. So I have ln of y, or natural log of y, equals natural log of x squared plus natural log of c minus natural log of x plus 1. So now I look at this, the plus means we're multiplying these, and then minus means we're dividing by that. So I get the natural log of y equals the natural log of, on top we have c times x squared, and on bottom we have the x plus 1. So now that it's condensed, 1 log and 1 log, you can cancel out, or you can really rewrite it if you want, but those will go away. So I get my final answer is y is equal to cx squared over x plus 1. And that's it. So that's using our log properties again. More manipulation of logarithms. And then tomorrow we're going to do more equations. I'll see you then.